Before we dive in, let's review the distance formula. Quick review on this. If we have a coordinate plane and we have one point here, we'll call it point A with coordinates x1, y1. And then we'll put point B here and we'll call those coordinates x2, y2. So they can be any 2 points on your coordinate plane. The distance between those points is this formula, and you should know this already. You subtract the x's and square it. And then you subtract the y's and square it. And when you're all done, you add those up and take their square root. That's the distance formula. Remember, the important thing, it doesn't matter which point you start with, it's that you are consistent. We have x1 first, so we have y1 first. The slope formula is our letter m, and that is the change in y over the change in x, which means y1 minus y2 over x1 minus x2. All right, figures are similar if they have congruent angles and proportional sides. You should know that already from previous lessons. If you don't, you need to learn it now. Similar figures mean you have congruent angles, proportional sides. There are several shortcuts to prove certain triangles are similar. So you don't have to check all angles and all sides. So let's step back to Unit 4. Unit 4, we did congruent shapes, which when they're congruent, all angles and all, well, I shouldn't say all, I need to say, sorry about that, all corresponding angles and all corresponding sides are congruent. So just keep that separate. There's two different things we have. We have congruent and we have similar. Last unit was congruent, this unit's similar. So for congruent, remember we had these shortcuts for triangles. We had SSS, ASA, SAS, AAS, and HL. That's all for congruent triangles. Now here today, since we're talking about similar, not congruent, we have three shortcuts. The first one is angle, angle. Notice when we use these, and you can see that right here up at the top of the notes, we use that little similar symbol to keep it separate. It's not such a big deal for AA because there is no AA over here in congruency. But for SSS and for SAS, you have to add that little similarity symbol because there's a difference between being similar and being congruent. So here's one of your shortcuts. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all you need here is two angles. Super nice. By the way, if you have two angles, don't you automatically have the third angle? Remember, the third angle theorem says that if two angles are congruent, then these third angles have to be congruent. And so technically, if you have AA similarity, then of course you also have AAA similarity, but that's not, we use the AA. So just use AA. You only need two congruent angles in order to prove your triangles are similar. So don't forget to look for vertical angles. Remember those vertical angles. So these two triangles right here, I could say triangle ABE is similar, one little squiggly. So triangle AB is similar to A goes with C, B goes with D, and E goes with E. So that would be my similarity statement right there for these two triangles because I have vertical angles and right angles, so I have two angles congruent. All right, next one. Don't forget reflexive. So this angle here is a part of both triangles. In order to say these two triangles are similar, though, I would need another set of angles. So let's say it's marked like that. Angle S is similar to itself, and angle S is in both triangles. So therefore, my similarity statement with these markings would be triangle SRT is similar to triangle SUV. And then finally here, we have parallel lines. So don't forget about alternate interior angles or alternate exterior angles or corresponding angles with parallel lines. You can get all those angles. So for example, this parallel line and this parallel line, we can have this transversal right here, and therefore this little angle right there is congruent to that little angle by alternate interior. We can also have this transversal. Whoa. Hold on, everyone. Okay, we can have this transversal right here, and therefore this little angle is parallel to that little angle, also by alternate interior. And then on top of all of that, with this triangle, hopefully you also see that we have vertical angles right here. So all our angles can be proved congruent, but the key right here is that we want to also look for alternate interior, alternate exterior, and corresponding angles. So therefore, we can say, let's see, we have triangle JKG is similar to triangle HFG. Make sure your letters line up, and that would be the AA similarity postulate for all of these. AA. Okay, moving on. Using the AA similarity postulate, explain why the triangles are similar and write a similarity statement. So therefore, you have to, in order to use, the only one you know right now is AA, so we need two sets of angles equal. So if I want to explain why they're equal, I'm going to say, well, angle A is congruent to angle D because they are both right angles. And then I'm going to say angle BCA, this angle right there, BCA, is congruent to angle ECD because vertical angles theorem. So therefore, those little three dots in a triangle is therefore triangle ABC is similar to triangle DEC. Make sure your letters line up by AA similarity postulate. Next one, explain why the triangles are similar. So now I'm on this picture. So if this angle is 43, then what is this angle? So the way I find that is I can see that B and E are both 90, right? But 43 does not equal 47. So the question is C 47? So to find angle C, I would say, well, angle C plus angle A have to be 90 degrees because B is also 90, and 90 and 90 make 180. So therefore, an A is 43. So angle C plus 43 is 90. So what does angle C equal? 90 minus 43, which is 47 degrees. So therefore, this angle is 47 degrees. So since C is 47 and F is 47, and B and E are both right angles, I have similar triangles. So now I need to write that out. So I'm going to say angle C is congruent to angle F. And then I'm also going to say angle B is congruent to angle E because they're both right angles. Therefore, triangle, now be careful, if I say ABC is similar, I have to get the right order. So angle A actually goes with D, B goes with E, and C goes with F by the AA similarity postulate. Okay. Another similarity postulate is side, side, side. If the three sides of one triangle are proportional, not congruent. If they're congruent triangles. So this is proportional to the 3 corresponding sides of another triangle, then the triangles are similar. So we're looking for proportionality here, not congruence for our sides. And then the last one is SAS. Remember, we're going to write this SAS with the little similar sign, and we're going to write this one SSS with the similar sign every time with that sign. If 2 sides of one triangle are proportional to 2 sides of another triangle and their included angles are congruent, then the triangles are similar. So if you are going to say AB, so here's AB, that side, and DE, AB to DE, that proportion is equal to this proportion, BC to EF. So these 2 proportions are equal. The included angle there is E and B. So in order to use SAS, you have to prove the 2 sides surrounding those equal angles are proportional. You have to prove this is true, that both of those fractions reduce to the same number. So here we go, number 3. Verify that PQR and STU are similar. So I'm looking at this picture, I see no angle measure. So therefore, my only option is going to be SSS similarity, right? So let's see if that works. In order for SSS to work, all my proportions have to be the same. So if I would put this little triangle on top of this big triangle, how would it line up? Well, I think I would have PQ on top of ST. I'm just writing out my proportions. And then I would have PR on top of SU. And then I would have RQ on top of TU. So those are my proportions. Let's see if it's true. So PQ is 3. ST is 4.5. PR is 2. And SU is 3. Finally, RQ is 3, and TU is 4.5. Notice I'm consistent. I put all the sides of the small triangle on top and all sides of the large triangle on the bottom. You need to be consistent with that. And now what I'm trying to do is prove these are equal, all 3 of those fractions. So you have a couple ways to do that. Sometimes it's easy because you can just see that they're true, and maybe you can see that. But if you can't, take the numerator, 3, and divide by 4.5 for that first fraction, and you get 0.6 repeating. I'm just going to write it down here, 0.6 repeating equals. Now what's 2 divided by 3? Again, 0.6 repeating. And then using your calculator, well, we already did that. 3 divided by 4.5 is 0.6 repeating. These all equal the same number. They equal 0.6 repeating. Therefore, the sides are proportional. That's what it means to be proportional. All the sides have to simplify to the same number. Okay, so since all my sides are proportional, I can say that triangle PRQ is similar to triangle STU. Make sure you line it up right. Oh, by the SSS similarity postulate. Okay, next one, which I wrote on. So let me erase that. Okay, verify that the triangles are similar. So therefore, when I look at these 2 triangles, I see an angle measure. Angle D is 70 and angle H is 70. So I see that angle D is congruent to angle H. That's my angle. So I'm going to go for side, angle, side. In order for side, angle, side to work, I have to have one set of congruent angles, which I have right there, angle D and angle H. But now I need to prove that this side right here to this side right there is proportional to these 2 sides, because those are the 2 sides that create that angle on both triangles. So what I need to do, let me just write that out. I have to show that DE compared to HJ is equal to DF compared to KH. Okay, so I need to prove that's true. I'm going to put in my numbers. DE is 2. HJ is 1. Does that equal DF is 5.8? And KH is 2.9. What do both of those numbers simplify to? Well, 2 over 1 simplifies to 2. So you can write that there. And then you can take your calculator if you don't know it already, and you can say 5.8 divided by 2.9 is also 2. So 2 equals 2. So therefore, my two surrounding sides are proportional and the included angle is proportional. So I can say, over here I would say DE to HJ is equal to DF to KH, because 2 equals 2. And so I have my angle and I have my two sides, side, side. So I have side, angle, side, and I can say triangle EDF is similar to triangle IHK. Make sure your numbers lined up by side, angle, side, similarity, postulate. The hardest one here is definitely the SAS, because you have to make sure that you are including, it is, if this is, let's say this is the angle equal to this angle, then you would have to use this side and this side and this side and this side. The two sides have to surround the angle that is congruent. Okay, now, finding lengths in similar triangles. Explain why ABE and ACD are similar. So why do I know that this small angle ABE and the small triangle ABE and the large triangle ACD are similar? Well, I have angle. I see that angle A is part of both of those triangles, and then this triangle is 90 and this one's 90. So prove the triangles are similar. I'm going to say, well, angle A is congruent to angle A by reflexive property of congruence. And then I also, hold on. I also know that angle ABE is congruent to angle ACD because they are right angles. Therefore, triangle ABE is similar to triangle ACD by the AA similarity postulate. So we did step 1. We proved the triangles are similar. I say prove, but really we're just explaining. We're not obviously doing a 2-column proof. And now I need to find CD. So CD is X right here. And this is how you can do that. Once you know your triangles are similar, then you know that all sides are proportional. If they're similar, the sides must be proportional. So therefore, I'm going to set up a proportion. And I'm going to say that the side AB compared to the side AC, so AB is the small triangle, AC is the big triangle, that comparison has to be equal to the side BE of the small triangle to the side CD of the large triangle. So I'm saying this compared to this is equal to this compared to this. That's your proportion. And so now plug in what you know. Well, AB is 9. A to C is 12. 9 plus 3 equals BE. BE, why are we not drawing here? Let's try again. BE, okay, BE is 5 right there, and DC is X. Now notice when I set up my proportion here, in this case I did the small triangle sides over the large. Be consistent. So now I have a proportion I can cross multiply, so 9 times X is 9X. and 12 times 5 is 60. So therefore, x is 60 divided by 9, which is 6.67 or 6.6 repeating, but that is the value of x right there. This is the rounded value. This would be the repeating way to write it. So this is how we can use our proportions. Once we have similar triangles, so we have to know they're similar. If they're similar, the sides are proportional, and you can set up a proportion. Let's do number 6. Little erasing. Okay. Explain why triangle RSV, so that would be this little one right here, is similar, not congruent, but similar to RTU. Why would that be? Well, I see that angle RSV is congruent to angle T. Those two angles are congruent. Now look at for S, I could not write angle S because there's 2 angles for S, right? So I had to use 3 letters for angle S, but for T, I only had to use 1. So anyhow, these 2 angles are congruent. And then I also see that angle R is congruent to angle R by reflexive. So therefore, I have 2 angles congruent. And so I can say that triangle RSV is similar to triangle RTU by the AA similarity postulate. So now I know my triangles are similar. So now I need to find a side. Now remember, if the triangles are similar, all sides are proportional. So therefore, where is RT? RT is right here, from R all the way to T. We'll call it X. So setting up a proportion, we'll do that right here. Proportion is 2 fractions equal to each other. So I'll do the small triangle side, RS, which is 10, goes with the large triangle side, X, the same way as the small triangle side, 8, goes with the large triangle side, 12. There's my proportion. I could write it out in letters. I could say I went RS is to RT as SV is to TU. There's it in letters. There's it with the numbers. Cross multiply. I have 8x equals okay, I have 8x equals 120. So then do 120 divided by x. I'm sorry, 120 divided by 8, and you get 15. So therefore, RT is 15. Okay? Another one, number 7. Okay, this is a proof, so we have to write everything out. So we are given that JMN, so this little triangle right here. Oh, I just wrote over something I'm going to need though, so get rid of that. We won't do that. But JMN is, and okay, we're not given, and we're given that we have triangle JMN and triangle JLK. So we have a small triangle and a large triangle. We are told that angle JMN is congruent with triangle JLK, and it's already marked. Those are congruent. So we're going to do our proof. We start with our given. We have triangle JMN is congruent to triangle JLK, given. Next, we want to prove that the triangles are similar. So when I have one angle, that's all I know, I don't have reflexive, I don't have any other angles, that means my only option is going to try to be to do SAS. And so to do SAS, I need to look at the sides that include that angle. So what I have is this side, and look at, I know both of those numbers. And then I have this side for the big one all the way, and then just a portion of it for the small one. So I know the measurements of my sides. So I already have the angle right here that was given. I need to prove that those sides are proportional. So that means I need to prove that KL to NM, so I'm going big over small, is equal to the side JL over JM. If that proportion is true, then I'm good to go. So I'm going to say then that KL is 16, NM is 12, and that equals 24 plus 8 is 32 for JL over 24. Are those equal? Simplifying that or using your calculator. So what you can do here to prove those are equal, you can, one, do cross multiplication. 16 times 24, does that equal 12 times 32? So 16 times 24 is 384. 12 times 32 is 384. So therefore, we can say that sides are proportional. We're going to put a question mark there. But now we can say that, yes, KL to NM does equal JL to JM. And then finally, we can say that triangle JLK is similar to triangle JMN by side angle, side proportionality. So we need to put reasons in here. This would be, I'm just struggling here with the reason for this. Let me see what I put here. Oh, I see what I did last time. Kind of wrote it differently. Let me just change this a little bit. All right, I'm going to say KL to NM is equal to 16 over 12, which is simplified to 4 over 3. That's called division property of equality. Get rid of that step. I'm going to say instead that KL over NM is going to equal 16 over 12, which is, again, 4 over 3, which is division property of equality. And then finally, I can say that these two are equal, because if this equals this and this equals that, that's the transitive property of equality. And so there's my sides and my side. So in order to use these, we have to have an angle and then two sides proportional. So sorry about the mess here. I should look at my notes more instead of just wander. So, okay, last, excuse me, last one. Given IH and TC are parallel. Prove WIH is congruent to WTC. All right, so we have parallel lines. Hold on, don't look at that anyone. Okay. IH is parallel to TC, given. So therefore, if these are parallel, we have a whole bunch of stuff. If I want to prove that WIH is congruent to WTC, first of all, I see right here they both have that angle. So I'm going to take care of that. Angle W is congruent to angle W. That's your reflexive. They have the same angle in both of those triangles. And then I'm going to say, because we have parallel lines here, we actually have two different things. I could have this angle be equal to that angle, right? Because this is the transversal, which works. So let's just write that down. Angle WHI is congruent to WCT. Corresponding angles in parallel lines. But I also, just to point out, you could have done the other one, this transversal, and then this angle would be equal to that angle. So either one of those would be fine. But finally, so I already have, here's an angle, here's an angle. Two angles are already congruent, so therefore triangle WIH is similar to triangle WTC by angle-angle similarity postulate. There you go.